Last couple sections here. So we're in lesson 3.4. Going in to get some coffee. They offer it in four different sizes. We got small, medium, large, extra large. There's 4 different types of coffee they have. I think you can read that on the little chart there. And then there's 7 different kinds of flavor shots. And so we want to use a table, or I'll probably use a tree diagram real quick to kind of organize this and model this scenario. So first I'm going to start with the 4 different sizes. You got small, medium, large, extra large. And then you got the 4 different types of coffee. You got the salted caramel, you got the original, the white, the Dunkaccino, and then you got those 4 for each of those. And then from each of these, we have the 7 different flavor shots. So each of those are going to have 7 as well. So tree diagram can get a little crowded, but maybe we can wrap it up in a little chart here where we do have the size. There are 4 of those. We do have the kind of coffee. There are 4 of those. And then we have flavor shots. And there are 7 of those. So the idea here is to figure out how many different ways you can order the coffee. Well, there's 4 different sizes times 4 different kinds times 7 different types of flavor shots. So we do 4 times 4 times 7. 4 times 4 times 7. That seems to get us 112 different coffees. So we've kind of used this earlier on when we were talking about outfits and the little number combinations. This is going to be the multiplication counting principle. So number 2 adds a little extra here where we can have a little add-on. So we can add whipped cream, chocolate syrup, or caramel syrup, or we can add none. So that's 4 extra ones, 4 extra things that we can have there. So we got that 112. We're going to multiply that 4 different ways. And now we have a total of 448 different coffees. So again, this is the multiplication counting principle that we're applying here. We're taking how many different styles we have, whatever we have, and figuring out how many of each of those we have and just multiplying them all through. So a couple more questions here as we went to pay. See a sign saying win free coffee for a year. Choose 4 different digits from 1 to 9. Create a 4 different passcode. Enter your passcode online. Match theirs. Win free coffee. So we want to figure out, all right, how many different passcodes could you choose? So they have to be 4 different digits. So again, this brings us all the way back. We've seen a problem like this before. We have 4 different numbers that we're trying to do. 1 through 9. Again, that's a total of 9 different digits. So whatever we choose, we have to choose something different. So we can have to subtract the one that we already used, and then we subtract the one we used in the second digit, so on and so forth. And then we'll take these 4 numbers and multiply them together to get how many different passcodes that we can use. And it turns out to be there's 3,024 passcodes. And then number 4, similar question. We want to use all the digits from 1 to 9 and create a 9-digit passcode. So we're going to have 9 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, we start with any digit 1 through 9. That's going to be 9 different digits. And we have to use all of them. So we have to use different ones every time. So 7, 8, 6. We'll be subtracting 1 because we've used one of the digits already previously. And then we get all the way down to the very end, and no matter what's left over, that's the number that we have to use there. So when we multiply all of these together, we will get a nice large number, and you might recognize this as 9. And that is 9 factorial. And what factorial means is whatever number that is, multiplied by every number, subtracting by 1 down to the number 1. So my calculator doesn't do that really quickly. So I'm just multiplying it on my phone to my side here. And you can check, maybe if you have the TI app or if you have the TI Chrome extension, you can do 9 factorial. I believe it's math, and then to the left, and maybe 4. It's in one of those math menus there. And then I'm pretty sure it's number 4. You're just looking for that exclamation mark. I think it's somewhere around there. Some important ideas from the text that we'll jot down, including factorial. All right, first we have the multiplication counting principle. So to find the total number of ways to do a process, multiply the number of options in each step. And we'll have an example real quick right below. So we got our first option times the second option times the third option. We want to put that down. For however many options you got. Next we have factorial. So that's any number with an exclamation mark after it. So if we have n factorial, and that's going to be n times n minus 1 times n minus 2, all the way until we get down to 1. 2 times 1 there. So for example, if we have 5 factorial, we have 5 times 4 times 3 times 2 times 1, which will end up being 120. And then finally, we want to talk about a quick way to do some of this, some of these counting actions, like the how many digit codes we can have, will be a permutation. So this is if order is important. You can use permutations to figure out the number of ways to order something. So again, that's if order is important. So we take our total number of things we want to order and how many we're choosing to order there. So n is the number the total number of items, and x is going to be the number of items that we want to actually put in order. So for example, earlier on we had these 9 numbers and we wanted 4 of them. So we can take those 9 numbers and order 4 of them. Let me go find it on the TI-89 real quick. Well, it'll be the TI-84, and I'll show you a video of factorial and permutations on the 84 when I get a different video recording. So once I have that and you have these notes down, we'll probably work on the next couple questions in class. And then you can move straight on to hamburger ordering, where the order doesn't matter, and we'll have more combinations instead of these permutations.